Here we're asked to sketch a graph that is a function for number one. So to sketch a graph that is a function on this one here, we're going to make sure that it can really be any shape that we want it to be. We could have straight lines, we could have curves. The main thing here for making sure that it's a function is that every input has only one output. So if I were to look at a certain x value, like the x value of 5, when I look up, I see that it only crosses our curve here, our purple curve, one time. Whereas for number two, it tells us to sketch one that is not a function. Well, in this situation, I could, again, draw whatever I want. The way that I would make it not a function is that at some point, maybe something that looks like this, where if I looked at the x value of 5, I would see that it crosses our red curve here more than one time. If we have a single input that has multiple outputs, that's what defines that something is not a function. For number 3 here, it says this graph shows the distance of a drone from its pilot, d of t, over t seconds. So that's kind of like our y value, and t is kind of like our x values. So which statement is false? It says for A here, the drone took off next to the pilot. Well, when we're taking off here, that's right at 0. And it looks like, we are at 0 distance or feet from the pilot. So I would say that this one here is true. The second one here says d of 8 is equal to 30. So if I look over at d of 8 here, that's saying like, d of t, or when I plug in the time is equal to 8. That would be d of 8. And we're saying is when the x value is 8, is the y value 30? And when we look at this here, it looks like it is at 30. So I would also say that B is true as well. Then the next one, the drone reached its maximum distance from the pilot at 10 seconds. When I look at 10 seconds here, let's do a different color here in blue. When I look at 10 seconds here, we see it's right around 80-ish feet. And that's not the maximum distance, because the maximum distance here looks at 90 feet, which is not at 10 seconds. So I would circle C here as my answer, because that one is the one that is false. Just to double check here, when we're looking at D, the drone's distance from the pilot is a function of time. Well, that's true because we have D of T. The distance is a function of time. For problems 4 through 6, h of t represents the height of a high jumper at the time t. They run for 4 seconds, jump over a bar that is 6 feet high, then hit the mat at 6 seconds. First of all, it says, is h of t a function? And I would say yes, because the person doesn't have two different heights for any time, right? So if I look at this graph here, at no point does a single x value have multiple y values. Also, again, in like real world situations here, at a certain time, they can't have two different heights. That wouldn't make any sense. For number 5, it says explain what h of 5 is equal to 6.5 represents. So h of 5 means when t is equal to 5 seconds. And so when I'm looking at 5 seconds, that lands right around here. And in this situation, it says that the y value is at 6.5. That's this point at the top here. And what does that represent? Well, it's saying that at 5 seconds, that is when the jumper is at its highest point. So the bar was 6 feet high, and it tells us that we made it over the bar because they jumped to a height of 6.5. Was that feet, maybe? Yeah, feet. For number 6, it says write the function statement that represents when the high jumper hit the mat at 6 seconds. So we would say h of 6, because at 6 seconds, that's when we hit the mat again. And it looks like the mat is on the ground because our y value at 6 seconds is 0. So my function statement here would be h of 6 is equal to 0. And that represents that the high jumper hit the mat at 6 seconds. Next one's here, problem 7 and 8. Here is a graph. Is it a function? First of all, I would say no, because if I'm looking at, let's say, 6 seconds here, I see that there is an output a little above 4 and an output here a little below 8. And so one input, an input of 6, has two different outputs. And so that would mean that it is not a function. write a story that this graph could represent. So, I mean, there's lots of different situations that you could write about in terms of, a thing can only be at one spot in time, right? Like I can't be at home and also at school. And so that's why certain situations don't really make any sense. One situation here is, let's say that we had, a paper airplane that we threw, and a piece of it fell off at 4 seconds, right? So if I have this paper airplane starts as one thing, if it splits into two things, well, now, okay, it technically has two different heights at a certain time because one piece is up here and one piece is down here. So again, you kind of have to be ingenuitive when you're coming up with these specific situations, because when you're going through it, it may not always make sense to you. But again, there's no real wrong answer. We're just looking for something that might kind of be represented by this representation. Again, this graph here is not a function, so I can't really call it a function, but I can say it represents some sort of data. All right, we're on to the spiral review, which is just the stuff that may not have been talked about in the most recent lesson, but is reviewing the old stuff that we still need to know. So there's two problems in this one here. We got problems 9 and 10. We got a graph that we're going to label g of x. Use the graph to complete the function statements. So the first one says, what is g of 3? So I'm going to look at where is 3 on this graph. It looks like it would land right around here. And when I look up what y value is it is hitting a y value of 2. And so in this one here, g of 3 is equal to 2. And the second one here says, hey, g of what would be equal to 6. So when I'm looking at this here, I'm saying g of what x value would give me a y value of 6. And I see here the y value of 6 is right here. It's actually our maximum value. And I see that the x value would be 8. So to write that correct function statement, I'd say g of 8 is equal to 6. So we got to understand function statements and how to write them.